Today we are covering lesson 5.4 on sum and difference formulas. Here are the trig sum and difference formulas we need to know. They are on the formula sheet or note card that reference it as. And they're in the top left corner. The biggest ones we're going to use are going to be our sine and cosine ones. So try to see a pattern in those. From these formulas, we will derive a lot of the formulas we will use in the following lesson. However, today we are just using these in several different ways. So looking at our pattern, let's see sine of u plus v equals sine of u, cosine of u plus cosine of u, sine of v. Looking at the minus, I see the same idea. The only difference is our sign change, right? Trying to look what's similar. Our signs are the same. What's different? Sine has the different pieces, cosine and sine, on the same side. Whereas when I go down here to cosine, cosine of u plus v equals cosine of u, cosine of v. These stay the same. Cosine of u, cosine of v on the same side. Minus, we've got different signs though. Our sign change. And then here's our sign. Right? Cosine first, sine second. Same thing with minus, but it happens to be our sign switches. So pattern. Sine keeps the same sign. Okay. Cosine doesn't, but it keeps the same pieces together. Tangent we'll only use on one problem today. So again, that's going to be one where we use on case by case basis. But basically, our numerator gets the sign that's between the two arguments. Moving on, find the exact value of the expression. You do need to know your unit circles. Again, for these, 0, pi 6, pi 4, pi thirds, pi half, and the different quadrants. Okay. Now, how can we make 11 pi 12, right? That's not on my circle. However, we can make this, right? We're looking for the u and v such that some number of pi 12 plus another number of pi 12 that will simplify into numbers I have over here will give me a way that I can compute and find this value. 6 over here is 2 pi 12, fourths are 3 pi 12, thirds are 4 pi 12, and half is 6 pi 12. We won't use that one as much. However, with 11 pi 12, we could say that is a 9 plus 2. Right? So 9 pi 12 plus 2 pi 12. I'm using a multiple of pi 4. We're going to use 3 pi 4, and 2 pi 12 is pi 6. And now we're just doing the formula. So this is sine of u, cosine of v. Same sign, it is sine plus cosine of 3 pi 4, sine of pi 6. Now we do also want to know our points. So again, as a note, 3 pi 4 xy value point is negative root 2 over 2, root 2 over 2, because we're in quadrant 2, for all students take calculus. Pi 6 is in quadrant 1, so they're both positive. And we've got root 3 over 2, 1/2. So plugging those values in, so those are the values we're going to use. Sine of 3 pi 4 is root 2 over 2, times cosine of pi 6 is root 3 over 2, plus cosine of 3 pi 4 is negative root 2 over 2. I might change our sign here shortly. And then lastly, sine of pi 6 here is 1/2. So we're just going to multiply those. I get root 6 over 4 minus root 2 over 4. And we can rewrite that as root 6 minus 2. Sorry, root 6 minus root 2 all over 4. You can't simplify further than that. Moving on. The cosine of 7 pi 12. Now we can use the same values we did last time and make this a minus. However, we're going to mix it up, and we'll make this cosine of 4 pi 12 plus 3 pi 12, which we can easier write as 1/3 plus 1/4. And this is the cosines are together, cosine pi 3rd, cosine pi 4th. Sine switches to minus, the signs are together, sine of pi 3rd, sine of pi 4th. So I need my points. Pi 3rd is going to be half root 3 over 2 And pi fourth is going to be both root 2 over 2. And so basically the x values multiply together on one side minus the y values multiply together. So we've got half times root 2 over 2 minus root 3 over 2 times root 2 over 2. And we'll get root 2 over 4 minus root 6 over 4, which equals root 2 minus root 6 all over 4. Now I would say that's a negative number, so let's quick look at our argument quick twice, apparently. 7 pi 12 is a little more than 1/2, and cosine of quadrant 2 is negative, so it does make sense this would be a negative value, and there's our answer. Moving on, we've got cosine of arctangent of 1 plus cosine inverse of x. We're going to call this tan inverse 1 for space reasons. But when we have these cosine of tan inverse, cosine of cosine inverse, we're going to need to make our own triangles to make sure that we get numbers that work. So, first writing it out, cosine, we'll write it out in the form cosine of tan inverse times cosine plus cosine of inverse x. We're going to just multiply it out. So we got cosine tan inverse 1 times cosine inverse x minus, switching signs, sine of tan inverse 1 sine of cosine inverse x. Looks like a mess. We'll actually clean it up quite nicely here. Tan inverse of 1. So normally I would make a triangle for this to see if it works, but you're going to find out this is in our unit circle, right? Tangent inverse means some angle has an opposite over adjacent of 1. 1 over 1 would give me this kind of look here, which is 45-degree triangle, right? Technically, this would also be root 2. So this is 45 degrees. We can just say these are pi 4. So we're going to also write that where the sine is. So because of that, I don't need to worry about my cosine inverse triangle. So cosine inverse triangle, drawing another right triangle, we'll call it theta. And this, again, cosine is adjacent over hypotenuse. So this adjacent over hypotenuse is going to be x over 1. Now we can solve for the last side, right? A squared plus b squared is c squared. So 1 squared minus x squared equals b squared. Square rooting, we're just going to rewrite that as 1 minus x squared. Now, rewriting what we have left. We've got cosine pi 4, cosine inverse of x. We can use this triangle to solve that. Minus sine of pi 4 times sine cosine inverse of x. So we won't get a nice number answer because of our triangles here, but we'll still get a little closer to simplifying. Cosine of pi 4 is root 2 over 2 again. Now cosine inverse of x, these cancel, but basically we're doing cosine of this angle, which is adjacent over hypotenuse, which is just going to give us x, minus sine of pi 4 is root 2 over 2 as well. But instead of a nice number, now we're doing sine of this angle, the same triangle, cosine inverse triangle, which is going to give us 1 minus x squared under a square root over 1. So that's going to be in our numerator. 1 minus x squared up here. Now simplify. Root 2 of x, we're all over 2, minus, these can actually multiply because they're both under a root. So we're just going to rewrite that as square root of 2 minus 2x. And there's our answer, out of 2. Next, some positive values here. We've got find the exact value of the trigonometric function given that sine of u is 4/5, where 0 is less than u is less than pi half, and cosine of b equals -12/13, where pi half less than b less than pi. So looking at these, it basically just tells you u is in quadrant 1, b is in quadrant 2. That's what that limit tells you. Second, sine of u is 4/5. We can solve a right triangle with that, right? So right down here, u is going to have a triangle where opposite over hypotenuse is 4/5. We make it look a little more like a right triangle. And then, because we know our Pythagorean triples, that's a 3, 4, 5 right triangle. A squared plus b squared is c squared, 3, 4, 5, 1. Next, our B triangle which we'll draw this way, because it's in quadrant 2, as an adjacent negative 12 over hypotenuse 13. This is also a Pythagorean triple with 5. So now that we know these two triangles, we're going to rewrite sine of u plus v equals sine u cos v plus sine v cos v sine u. Sorry, cos u sine v. That's it backwards. From our sheet, and now we have two of the three. We've got 4/5 given to us. We've got negative 12/13 given to us. Plus, we can find cosine of u using the triangle. Cosine is going to be 3 over 5 from the triangle on the left. On the right, we can find our sine of v, which is 5 over 13. Now, it's in quadrant 2, so sine is positive there. So we didn't need to have a negative sign for that opposite. Now, multiply and simplify. Now, some may want to cancel these 5s here, but you'll realize that we have 65th, right? 65 is our denominator of both left and right side, so just leave it. We'll have negative 33 65th. Next, we're doing the same problem but with cosine. So I'm going to bring those same triangles over here. We don't need to repeat, draw these again. We're just going to copy and paste them over. And we're going to use them again. The same problem, reading it. Now we're just finding cosine of u and v. So cosine of u and v equals cos u cos v minus cosine sine u sine v. And so we're doing the same exact thing, just slightly different order. So cosine of u is 3/5. Right, the last one, cosine v already given to us, negative 12/13. Minus sine of u is 4/5 given to us. Sine of v is 5/13. Multiplying negative 36 65th minus 20 65th gives you negative 56 65th. A little quicker when you've already got the triangles, otherwise it can be a little bit of a lengthy problem. Next, verifying the identities. Yes, these identities, although I showed you graphically how they work, can be proved using these formulas. So cosine of u minus v, right, what we're using, so cosine pi half cosine x plus sine pi half sine x. And what do you know? Pi half is the point 0, 1. 0 for cosine values, 1 for sine values. So 0 cosine of x, 0 plus 1 sine of x. That left side is going to cancel. We get sine of x, which matches what we were trying to do. Next one, tangent of x plus pi minus tangent of pi minus x equals 2 tangent of x. Okay, so tangent of x, get out your trusty piece of paper to follow along that first page. We're going to have tangent u plus v. Now tangent of u is x, tangent of v is pi. Over 1 minus 1 of each. Multiply. And then we've got minus tangent, and now it's flipping. Notice when we have the minus sign here, that's going to be in the numerator, so tangent pi minus tangent of x over 1. Now it's going to be plus down here, tangent pi, tangent x. And we need our point for pi. Pi's point is negative 1, 0. And again, tangent is y over x, so 0 over negative 1 would give us 0. So everywhere there's a tangent of pi, it's 0. So this 0, 0, 0, and now when we put it together, we've got tangent of x plus 0, so I'm not going to write it, over 1 minus tangent of x times 0, so that's 0, minus 0 minus tangent of x. There's where that plus tangent comes up from, and then 1 plus 0 times tangent of x. So we've got a tangent of x over 1, double negative, right? It's going to be plus another tangent of x equals 2 tangent of x. Sounds good to me. Next, find all solutions in the interval 0 to 2 pi. Okay. So sine of x plus pi thirds plus sine of x minus pi thirds equals 1. Okay. So set it up. We're going to do sine of x cosine pi thirds plus sine cosine of x sine of pi thirds plus sine of x cosine pi thirds, and we're going to space here. And now these keep the same sign when we switch minus cosine of x sine of pi thirds. So, reminder, what is pi thirds? Pi thirds equals the point 1/2 root 3 over 2. So, wherever we've got a cosine, we're going to write half. So it's half sine of x plus root 3 over 2 cosine of x plus another half sine of x, 2 halves make a whole, minus root 3 over 2 cosine of x. That's kind of moved down for this overload here. And we've got two pieces that cancel. And once we simplify here, then we'll set it. We've got half plus half sine of x. So sine of x equals 1. So where does sine of x equal 1? Using our unit circle skills, right? Sine of x equals 1 right here, pi half. And that's the only spot. So x is pi half. Did not say list all answered, period. It just said between 0 and 2 pi. Last one here is cosine of 60 degrees, cosine of 10 degrees, minus sine of 60 degrees, sine of 10 degrees. And it says to write the expression as sine, cosine, or tangent of an angle. Okay. So basically, it wants us to use the formulas we just used, but we're using them backwards. This is already cosine of u, cosine of v, minus sine of u, sine of v. Looks like which one, right? Cosines are together, tells you this is cosine. The sine is always flipped for cosine. So this is going to be cosine of u plus v. Well, u is 60 degrees. V is 10 degrees. So 60 plus 10 will give us cosine of 70 degrees. That wraps up the lesson for the day. The homework is posted on Moodle, so feel free to get it out there.